Now let's look at compound events. So compound events are events that consist of one or more single events. So they can be either dependent or independent of each other. So let's look at this example to show both cases of dependent and independent. So we have a bag of marbles, and inside it there are 4 red colored and 6 blue colored marbles. So let's look at the first case where we first pick one. And then we put it back in, then pick another. So in this case, this is actually an independent event, since picking the next one does not affect the picking of the first one. So let's say we find the probability of first picking a red one, then blue. Now, the probability of picking the red one in the first go is just 4 out of 10. Now, since we put it back in after we pick it, so there are still altogether 10 marbles in the second try. And then the second probability of picking a blue one would be 6 over 10. Now, this is equal to 24 over 100. And we divide this by 4. We get 6 over 25. So the probability of picking first red then blue becomes 6 out of 25. Now let's say we have a different game. Now instead of putting back in, we first pick 1 without putting it back in. Pick another. So in this case, this is the dependent event, because the picking of the second marble directly relates to the picking of the first marble. So let's count the same probability of first red, then blue. Now, the first picking has nothing changed because the marbles are still inside the bag. So picking red first, it's still 4 out of 10. But now since we did not put the marble back in the second try, there are only 9 marbles left in the bag. And since we wanted to pick a red one, the blue one doesn't change. So we still have 6, but instead of 10 now, we only have 9 marbles left. So if we multiply this, we get 24 over 19. And this is equal to 12 over 45. And I guess we can divide this again by 3 to get 4 over 15. So you need to be careful when you are calculating dependent and independent events, because they give you different answers.